Hello friends, what's up? My name is Raghav Raja. You would have seen your favorite fast bowlers on screen, and you would have seen that there's a small meter on the screen which says that this bowler, so and so bowler, has bowled at 140 kilometers per hour or 150 kilometers per hour. And we have super fast bowlers as well, we have spinners as well, and for all these kind of bowlers, you get to see their bowling speed on the screen. In today's lecture, we'll basically talk about the rate of change of motion or the rate of change of distance or displacement, and we'll consequently jump into the concept of speed and velocity. So let's get started. And let's also try and distinguish between speed and velocity. How are speed and velocity actually different from each other? So I'll just make two columns over here, speed and velocity. Now, we all have learned in our previous classes that speed is basically defined as the distance traveled by a body per unit time. So, if you see a fast bowler bowling at 140 kilometers per hour, and if you see a spinner bowling at 75 or 80 kilometers per hour, you say that the fast bowler is fast because when he throws the ball, when he or she throws the ball basically covers the same distance of 22 yards in a lesser amount of time, and that's how you say that that particular bowler was fast. So, if you talk about the units of speed, distance, which can be measured either in meter or kilometer, and time, which can be measured in seconds or hours or minutes. So, speed can be expressed as meter per second or as kilometer per hour. Now, since we learnt in our previous lecture that distance is a scalar quantity, it does not have any kind of direction associated with it. So, as a result, speed is also a scalar quantity. We also learnt in the previous lecture that distance can never be negative. So, if distance can never be negative, then speed also cannot be negative. So, it cannot be negative. Now let's talk about velocity. How is velocity different from speed? Velocity is defined as the displacement covered by a body per unit time. Again, the units of distance and displacement are same. You can either express them in meters or kilometers. So consequently, speed and velocity have the same units. You can either express velocity in meters per second or kilometers per hour. Your choice. Now, displacement, as we learnt in our previous lecture, is a vector quantity. Along with magnitude, it is dependent on direction as well. So, consequently, we can say that velocity is also a vector quantity. Now, displacement can be zero. It can also be negative. So, velocity can be zero or it can have negative values or values lesser than zero. So this is the difference between speed and velocity. But there also comes a stage where you say that speed and velocity can be the same. We learnt in our previous class that distance and displacement can be same only when an object travels along a straight line or in a straight path. So if an object is traveling in a straight path, then speed and velocity will also be equal. You can make a note of this statement because it's very, very important for you to understand uh, the condition where speed and velocity become equal. So speed and velocity become equal when the moving object travels in a straight line. Why? Because in a straight line, distance and displacement are the same. That is why speed and velocity also become the same if an object is traveling in a straight line. Simple. I don't think so. Things are getting very, very tough over here. So let's just try and analyze the various types of motion. I know it's something very simple, something that you've studied in your earlier classes as well. So I thought let's have a small recap of the same because we didn't have it in our previous session. So motion can be categorized as rectilinear motion, periodic motion, oscillatory motion. So rectilinear motion is basically motion in a straight line. Motion in a straight line. Oscillatory motion is nothing but to and fro motion of an object. And periodic motion is repetitive in nature. It is repetitive in nature. It repeats itself after regular intervals of time. Now, all of you must be having a question that if oscillatory motion is to and fro motion of an object, which is somewhat analogous to a repetition, and periodic motion also has a definition of being seen as a repetitive kind of a motion, then what is the difference between them? Okay, let me give you a simple example. Let's say you have a pendulum, and here's the bob of the pendulum. Let's say it has a mass of m. Now, if you displace the pendulum will basically oscillate or move to and fro between the points A and B. And then the pendulum would love to come back to its mean position. So, this is the mean position where the pendulum actually wants to come back. At the same time, let us look at an athlete who's basically running around a circular track. So let's say he starts from this point A and he is running around this circular track. So in the second case, the athlete is moving around a circular path, starts off from A, goes back to A, again, again, again. The same type of pattern basically repeats. But is he moving to and fro? Is he oscillating between 2 points? No, right? So this makes us come to a conclusion that all oscillatory movements can be called as periodic. Why? Because there is some element of repetition. But all periodic motions or all periodic movements cannot be called as oscillatory because the athlete is not moving to and fro between 2 points. His motion is repetitive, but it is not between 2 points. It's not to and fro between 2 points. So that's the difference between oscillatory and periodic motion. Now, there are two other categorizations of motion. One is uniform motion and the other one is non-uniform motion. Let us have a look at these two kinds of motion: uniform motion and non-uniform motion. Let us look at the difference between these two terms. So an object is basically said to undergo uniform motion when it covers equal distances in equal intervals of time. So equal distances, equal intervals of time. For example, you start off from some random point. Let's say you start off from home and you have to reach school. And let's say the distance between your home and school is 12 kilometers. And you are basically covering 1 kilometer in 5 minutes. And you follow that pattern. So you cover 1 kilometer in 5 minutes, then 2 kilometers in 10 minutes, then 3 kilometers in 15 minutes. And consequently, a pattern is formed, a uniform pattern is formed. So that kind of a motion is called as uniform motion. A very cool example of non-uniform motion can be driving in a situation of traffic. I am pretty sure that all of you have experienced this situation of heavy traffic in Delhi and NCR, where you get some space to drive fast or ride fast. You're able to cover that distance. At times you get stuck. So in those kind of situations, you are not covering equal intervals of distance and equal intervals of time. So in the case of non-uniform motion, unequal distances are covered in equal intervals of time. See, time will proceed uniformly. So that's why I've mentioned equal intervals of time. Whereas distances can be unequal. If you're stuck in traffic, you're not moving, right? There is no change in your position. You see a free road or you see the highway, uh, you get to drive fast. You can cover that much of distance. So you're basically not covering equal intervals of distance in equal intervals of time. So if I draw a graph of uniform motion, although we learn about graphs in detail, so let's say this is distance on the y-axis and time on the x-axis. So the graph in case of uniform motion looks somewhat like this. If I assign some numbers over here, it will become easier for you. Like let's say 1 meter and 1 second. Let's say this is in second, this is in meter, then 2 meters and 2 seconds. Similarly, you have 3 meters and 3 seconds, and then n meters and n seconds. So there is a pattern. After every 1 second, you're covering 1 meter extra. So that becomes a pattern of uniform motion. There's a consistency in motion. So you can say that there's some uniformity, there's some consistency. Why? Because this object or this moving particle is covering equal distances in equal intervals of time. Now let us talk about non-uniform motion. So again we have distance. I am writing dist on the y-axis. Distance is in meters. Time is in seconds, and this graph might not be a straight line graph. It can be somewhat like this. Let's say somewhat like this. Then maybe there's no change in distance. Then maybe there's some kind of a linearity over here, right? So then maybe there is again some kind of pause. Then again the motion spikes up. So clearly you can see that the values on the y-axis, the values of distance in the y-axis are not changing uniformly with respect to time. So this is a case of non-uniform motion, although we learn about graphs in detail, right? So don't worry if you don't get this. Once we start off with graphs, this will become more clear eventually. Okay, so let me just start off with something simple. Okay, so you have two values of speed in kilometer per hour, and you're supposed to convert this to meter per second. How do you do that? Now, I have a simple conversion for you. I'll share that with you right now. So let's say you want to convert 1 kilometer per hour to meter per second, and there is some conversion factor that you want to know. So 1 kilometer, so kilometer over here can be converted into meters as 1000 meters. 1 kilometer can be written as 1000 meter, and in the denominator you have hours, right? And 1 hour can be expressed as 3600 seconds. Basically 1 hour is equal to 60 minutes, and 1 minute is equal to 60 seconds. So you have 60 into 60 seconds, which is 3600 seconds. Now two zeros get cancelled over here, so you have 2 times 5, that's 10, and 2 times 18, that's 36. So 1 kilometer per hour is basically equal to 5 by 18 meters per second. So now I think so it will be very easy for you to convert these two values into meters per second. So do mention your answers in the comment section, and if you have any queries with this conversion, you can always let me know. So let's start off with the first part, 126 kilometers per hour. So you multiply this by 5 by 18, and this is 18 times 8. So this gives you 40 meters per second. Similarly, let's look at the other value, 72 kilometers per hour. Again, you multiply this by 5 by 18, and you have 18 times 4, that's 72. So you get 20 meters per second. Very simple, not very hard. So let us look at some interesting numericals. Okay. So over here it's given that in a rectangular track of length 4 meters and width 3 meters, an athlete covers 2.5 rounds in 100 seconds, and you're supposed to find the speed and the velocity of the athlete. Now let's draw a rectangular track first. So this is our rectangular track, A, B, C, D, and this is 4 meters. Let this be 3 meters. Okay. And you're given that an athlete covers 2.5 rounds in 100 seconds. So if you want to find the speed and the velocity of the athlete, let's start off with speed. Speed can be expressed as distance upon time. Now we have to find out the distance first. How do we do that? We are given that the athlete covers 2.5 rounds in 100 seconds. So distance will be equal to 2.5 times the perimeter of the track, or the circumference or the boundary of the track. So in one round, the athlete basically covers 4 plus 3 plus 4 plus 3. So this is 8 plus 6. That's 14 meters in one round, right? So what is the distance that this athlete will cover in 2.5 rounds can be calculated using 2.5 into the perimeter of this field, and the perimeter can be expressed as 2 times the length plus width. So you have 2 into 4 plus 3, which is 2 times 7, and that gives you 14 meters. So the distance in case of 2.5 rounds will be 2.5 into 14, and let's do the math. So 5 times 2 is 10, 5 times 5 is 25, 2 times 7 is 14, 5 into 7 is 35. So the athlete has basically covered a distance of 35 meters in 2.5 rounds. So if I am to find the speed of this athlete, the speed will be distance upon time, and now we have the value of distance. So speed will be distance, that is 35 upon time, that is 100 seconds. So the speed becomes 0.35 meter per second. Okay. Now to find the velocity of this athlete, we need to have some knowledge of displacement. So velocity is displacement upon time. Again, you have your track over here. This is 4 meter, this is 3 meter, this is again 4 meter, and this is 3 meter. So you have A, B, C, and D, and you're given that the athlete is basically covering 2.5 rounds of this track. So let's say the athlete starts from point A. So from point A he moves to point B, then to point C, then to point D, and back to point A. This is one round. Again, he'll cover another round. So 1 plus another round, that's 2 rounds, and 2.5. So he starts from A, moves to B, and then moves to C, and stops right there. So this distance or this path over here becomes the displacement of the athlete, and this can be easily calculated using Pythagoras theorem. So displacement becomes 3 square plus 4 square, and you have the time as 100 seconds. So this is 9 plus 16 and you have 100 in the denominator, so this is 25 upon 100, rather root 25, so root 25 is 5, and the velocity of this athlete consequently becomes 0.05 meters per second. Cool? I think so we are good to go. Let us have a look at another numerical, very interesting. So this numerical says Anand leaves his house at 8:30 a.m. for his school. The school is 2 kilometers away and classes start at 9 a.m. If he walks at a speed of 3 kilometers per hour for the first kilometer, at what speed should he walk the second kilometer to reach just in time? So for these kind of questions, what we can do is we can draw a diagram. So let's say this is point A from where Anand starts, right? Let this be his house. So let this point be his house, and this is some point B where he walks at a speed of 3 kilometers per hour for this first kilometer. So let this path length be 1 kilometer, right? And then from point B to point C is another 1 kilometer, because you're given that the distance between his school and his house is 2 kilometers. So point C is school, and Anand basically starts at 8:30 a.m. and he is expected to reach school by 9 a.m. so that he doesn't get late for his class, right? And you are given that he walks at 3 kilometers per hour for the first kilometer, that is between the interval AB. So from the diagram and from the question itself, it is very clear that Anand takes half an hour or 30 minutes or half an hour to reach school, right? So if we can find the time taken by Anand to reach point B from point A, it will become very easy for us to find out the speed at which he should walk the second kilometer, that is the path of BC, right? So let's try and find the time taken by Anand to reach point B. Let's call it as TAB. So time is basically equal to distance upon speed. We all know that speed is equal to distance upon time. So time is basically equal to distance upon speed, and we are given that Anand has covered 1 kilometer and the speed is given as 3 kilometers per hour. So eventually you get 1 by 3 hour, and this can be converted into minutes as well. So 1 hour is equal to 60 minutes. So 1 by 3 hours will be equal to 1/3 of 60, which is 20 minutes. Right? Now, one thing is very clear. If he is taking 20 minutes to start from point A and to reach point B rather, so he has to cover the remaining part BC, or the remaining distance BC, in 10 minutes. Now, if we find out his speed in the second kilometer, which is equal to distance upon time, and the distance is given as 1 kilometer for the interval BC, and the time over here is 10 minutes. Now 10 minutes can be written as 1 by 6 hours, again standard conversion. That if 1 hour is equal to 60 minutes, then 10 minutes will be equal to 1 by 6 hours. So this is basically equal to 6 kilometer per hour. So Anand has to cover or walk. So Anand has to walk at 6 kilometers per hour so that he reaches school on time. I hope that's clear. Now let us move to two very interesting concepts: average speed and velocity. So average speed, let's try to understand this concept with a very easy example. Let us say I start from point A and I cover a distance of d1 and it takes some time t1. Then from B I move to a point C, distance is d2, time is t2. From B I move to point C, and from C I move to point D, so distance is d3, time is t3. Now average speed is nothing but the total distance travelled by an object, total distance upon total time. So if I find out the total distance over here, it's basically d1 plus d2 plus d3, and the total time is t1 plus t2 plus t3, and again it has the same units, meter per second or kilometer per hour. Now if we want to find the average velocity, so that will be again total displacement upon total time. And the same properties, that average speed is a scalar quantity. It can never be negative. Average velocity on the other hand can be negative or it can be zero. Why? Because the displacement can be zero or negative, and average velocity is a vector quantity, average speed is a scalar quantity. So I hope you like this lecture on speed and velocity. If you like this lecture, do hit the thumbs up button and subscribe to my channel for more stuff coming soon. Till then, take care, stay safe and happy learning.